So as we were explaining in the previous slide, previous video, so the two centroid based algorithms, k-means and k-mode. So I will explain the working of k-means. In k-means, we assign the value of k beforehand to the algorithm, and algorithm does not decide the value of k. So here how it is done is, when we assign the value of k, it might be 2 or 3, but in this diagram it is given 3. So k is equal to 3 means 3 centroids are assigned to the algorithm, that is to the input data. So when we assign, it becomes 3 clusters. That means the data similar to this centroid are grouped together, this centroid are grouped together, this centroid are grouped together. So until and unless all the data points are converged to one or another centroids, the this um, assignment of data points to the centroids are done iteratively again and again till compact clusters are formed. The one data point that is not at all similar to any of the centroids, they are considered as noise. That is the outlier. Okay, so this is how k-means work. So k-mode is also the same thing, but that works for the categorical data and this works for the numerical data. Now we can summarize this k-means algorithm into now few steps. This slide is basically what I have told before. It is first the initialization comes, that is we select the k value, then assignment comes. Okay, that means we are assigning each data point moves to the closest centroid. Then we are recalculating. Okay, centroids, we are just calculating whether this data point is will move to this centroid or the other centroid, is just by calculating the mean of all the data points, and this step goes on and goes on until maximum iterations is reached. So what are the limitations? As I've told before, we assume the value of k. So when you change the value of k, the output algorithm's output might change. And we always assume that variance, that means something varies. Okay, variance is equal for all the clusters, and level of convergence is same, we all assume that. And and it is sensitive to the noise outliers. The advantage is, it is the most popular one. It does work for large data sets, and it is a very straightforward, very easy algorithm. People usually prefer it. And now next comes the implementation, how we are going to do it in Python. This k-means is equal to, we give the number of clusters, that is a k value here, and how many iterations it should happen. And this is a fit method, that is to predict the model. This creates the model in Python. Okay, so where and all we use this k-means is in image segmentation, customer segmentation, anomaly is the defect detection, genomic data analysis. Okay, so next we will move on to data density based algorithm. Density based algorithm, in this picture itself you can understand that they are tightly packed. See, all the data points, they move to one high. These are the high concentration of data points that are similar in all the ways. These data points are all similar data points joined tightly packed in one way. So I'll explain this even more detail in the next video. Thank you.